Morning.
Look who it is. What's up?
Another fun day. Another fun, exciting night cleaning up homework from like 6 weeks ago.
Oh, yeah, I can't.
It's the hardest part is going back and trying to smooth it all out, make it look better without using the stuff that we learn now. It's
Well,
all like
at this point, you can.
it's like you're trying to show, hey, look at all the stuff I can do with just CSS, and it's like, cool, don't put a bootstrap link in there.
Yeah.
And it's like, hey, all of this stuff is just supposed to be JavaScript, no jQuery, and it's like, wait, how do you do just JavaScript for this?
Yeah, I don't even. I went back and redid the quiz, and it was like mostly just JavaScript, the coding quiz, and for the first it took me like a little bit to be like, oh, okay, here we go again.
Sounds like fun.
Yeah.
The whole time I went back to that coding quiz as well to do it, and they're like, cool, yeah, hey, this whole push into local storage would work a lot better with SQL.
It would. Most of the time. But you'll still use local storage. It's not like you won't use local storage. It's just different.
I was talking to Matt, I think yesterday, about getting the README generator, like add a bunch more stuff to it, and like, cool, now I can actually just use this for doing the README generators for all the other projects if it's good enough.
Totally good.
Question on that. I've seen a handful that have like video clips embedded in the markup, and I Googled it and found some like okay stuff that worked all right, but I didn't know if there was a way to have, like, you can use an image tag in Markdown and put, have your CSS type code as attributes to make it smaller, change color, do whatever. I didn't know if they had something like that for videos.
Well, there's a video tag in HTML, so you can literally just put HTML in there. If you have like an MP4 or something like that, but most of the time that's GIFs or iframes from YouTube.
And that's what I had found on it. They're like, yeah, you can just do GIFs. I'm like, cool. I just want to see if I could just throw the whole MP4 file in there and just kind of have it play on a loop.
You could. You would just use a video tag for that.
I use this thing called it's like record.io. It's called recordit.co, and it will take whatever, so it'll allow you to record your screen, and then it automatically just makes a GIF URL for you and stores it for you, and you can just like dump that in the link tag.
Oh, that's neat. Yeah, because I just use OBS for doing all my screen recording, but it's like you still have to, if you want to edit it, you have to put it in like Adobe Elements or something.
Yeah, this one automatically just gives you a GIF back.
Nice.
I have a question, Eric. So I'm doing this homework, the eat the burger, I went tacos. And so when I am doing my button click event, so button click brings it to the screen and creates like a list element, and then when the get route, the API/all get route, I also add like the data ID, which is the ID from the actual taco, and then I also append that to the button so they're linked somehow.
Sure.
But when I'm looking in my on the browser tools, the developer tools, the data ID is not showing up until I like actually hard refresh the screen.
So, and are you using like jQuery, like find element.data to set it?
Yes. Well,
Right.
I actually in the for loop, I just set a variable that says taco ID equals data dot index dot ID.
Okay. And you're doing that in the in your front end code?
Yes.
Okay. Actually, let me just. Is your repo current as of right now?
So I made another repo.
Okay.
Yeah. 1 second. That one just wasn't going down.
Yeah, just slash me a link to that real quick,
Yeah.
just so that I can see it. It'll make it a little bit easier than trying to describe it.
Yep.
It's early enough in the morning that I'm like, I should have this written down.
And I woke up and I was like, ooh, I got this. I know exactly what to do. And then I started looking at it. I was like, ooh, my brain isn't ready. Come on.
But yeah, a nice thing is that you can take all of those techniques we learned from making views and you can just run them in the front end. The only difference is that you'll be using jQuery to put them somewhere on the page rather than working with the whole page at once. But you can still use it to refresh groups of things if you want to use that style.
Yeah, we went down the chirpy road. We were like looking at like what is most like this from the examples we had used so far, and chirpy was pretty similar, so we kind of adapted what we did in that chirpy example too.
Sounds good. So taco.js. Attribute class button data taco ID. Wouldn't that be data ID or something like that on line 40 in taco.js?
Well, I just set a variable underneath on 38.
Yeah, like let's right, but I'm talking about the like when you grab the taco ID, wouldn't you want to label the attribute data dash ID?
Yeah, I tried that and it was.
Well, remember you'll have to put that in a string because if you just say data dash ID and for the to append button with all those different attributes, if you try and do data dash ID, you by itself that's not a valid like variable name, so you have to put it in quotes when you do stuff like that.
Okay, so I did that in the beginning. Okay, now I put it in quotes now.
Then at least that's the way we usually do it, and then I would have to check your other JavaScript to make sure that that actually uses that when you click on it. Let's see.
Which I haven't started quite yet. That like the on click down here is what I was just trying to make sure that it was up there consistently.
No worries. And then there's a stray comment in there, but I'm sure you can work from that. Yeah. Any other questions, folks?
Hey Eric, do
Hmm.
you know if there's a limit for your video size that'll go into a markdown on README?
Uh, Not particularly. It's just going to be how long you can upload or load it from somewhere. For example, GitHub has limits on how big they'll let of a file they'll let you, or a single file they'll let you upload.
Okay.
But if you have your own like private repo or not private repo, but like private site that allows you to have like a 2 gig file, you can link it in there. Everyone's just going to be like, mm.
No, I copied over from the W3 schools what they wanted for a video uh, in Markdown, and everything seems to work. The poster and everything, the video just won't play.
It might just still be loading in. You
Mm.
might look in your network tab and see if it's if something's happening there.
Do you know? So I'm still just in VS Code trying to get it to show up in there.
Oh, okay. Um,
I don't know if that's something that like it doesn't like maybe.
I just push up your branch and then look up on GitHub and see what happens.
Okay.
Because the previewers aren't necessarily as good as the full web browsing thing will be.
Fair enough. Fair enough.
Hey Eric, can you just go through this ORM peripherally, like what it actually does? You're muted.
You're muted.
Sure thing. All right. So, what the ORM is for? The ORM is mostly there out of convenience. What this lets us do is separate our SQL thinking from our JavaScript thinking and use our ORM as the bridge between the two, so that it's very easy to think about stuff in terms of JavaScript. Now I don't have to think select star from chirps. I can just go, oh, it's a chirps dot find all, etc. So, and another nice thing about the way we do it is once we connect to the database, we can keep all of that as a result of the JavaScript files. We don't have to have a big SQL statement for that. We still, or a good big schema file. We still might keep seeds or other things like that. Or we might even write a program that uses the ORM to do that. But this is all about not having to think about this and instead thinking about it in this, that'd be chirp.findAll because it's singular, to get all of that information is essentially what we use it for. Do you have to have one? No. Like we've obviously written web applications without them, but it's also really nice to have them because then it's a lot easier to find all of these different pieces. We'll see later that some of the different queries are easier to set up as well. And it kind of gives us a layer to hide some of the complexities in a model away from the rest of the program.
Okay.
Does that answer your question?
Yeah. Thank you.
And we'll get some more practice with that today, and that'll help make it clearer. Any other questions, folks? All right, folks, it's basically about 10 o'clock. So let's go ahead and get started. The first thing I kind of want to do is do a review. Do a little bit of a review of what we talked about last time before we dive into some additional content. Cool. So let's start out with what is Sequelize? What is Sequelize?
It's a library that allows us to access SQL in a different way, or split up SQL.
And we learned an acronym for that. What would we call that? We call that an ORM, right? So that's an object relation mapper. And remember the map function. It takes something and then translates it into something else. Same thing's happening here. Instead of thinking about, hey, we have these SQL queries, we don't want to have to write all of that SQL ourselves. We'd rather be able to leverage these pre-existing formats. Hey, here's a table. And then I want to be able to just get that information pretty easily with JavaScript. So Sequelize specifically works with Node and JavaScript methods. There's other ORMs out there for different languages, like one of the more famous ones is probably Active Record for Ruby on Rails. There's NHibernate and Hibernate for .NET and Java, respectively. So ORMs are by no means restricted to JavaScript in any way, but Sequelize, our particular one, is. And it's a lot easier rather than typing out all the SQL code ourselves. A lot of it's already built for us, so we can get straight into the usage and not worry so much about the translation between the two. Cool. So what is a Sequelize model? First of all, what do we use it to represent?
A database or a table?
Yeah, what do we use it to represent? And correct, it's our representation of a database table. Usually it's in the singular case, and then our table is the plural version of it is our table, and that's just adopting the different naming conventions from SQL. SQL tends to put everything as a plural, and then the model tends to be the singular version of it. So when you see that, or when you're trying to remember that, that's what happens. Now, we've learned a couple of different methods from Sequelize, especially that are CRUD related. So Sequelize CRUD methods. Let's go ahead and say create, read, update, delete. What are the ones we've seen so far? For any of them, doesn't have to be in order.
Destroy.
So we've got destroy. I'll write that as model.destroy. What else?
Create.
Model.create. What else?
Update.
Update. What else?
Model.findAll or model.findOne.
Mm-hmm. And in this case, we've kind of seen two. And then there's other finds like find by ID, and then there's other ones like create or update and etc. But we know how to work with our different CRUD actions. And this helps us to start figure out what do we do with each one of these? What are they for? How do we translate stuff between all of these different layers, especially when we start out with something relatively simple? So if I'm making a to-do list and I want to make a new to-do, obviously there's the front end for that, but from the back end perspective, that starts with a route, which then talks to our model, which then talks to our database. So if I want to make a new to-do, which one of these is that? Of the CRUD actions?
Create.
That would be create. So let's start with the route. What would the route look like for making a new to-do?
Is this with using the Sequelize method? So you do a create a const and set it equal to a create function?
Well, in this case, we're using SQL. So let's say that those things already exist. So our route is, what does the browser call? What does the browser call to get us kicked off?
To-do.create.
Well, that would be part of the model.
App.post.
App dot.
Yeah, so we're going to need to post something. And what's my URL going to be?
API \new.
Well, I would say to do in that case, because it describes the resource. Now, if we have, that's fine. You can do it and say new. That would absolutely work. But this way, we're sort of identifying the resource that we want to work with really easily. So we can then call the to-do.create method on our model, which in our database ends up writing insert into to-dos. And so already, just from make a new to-do, you could see this. Let's say that we wanted to update an appointment by ID. Let's say that we are making like a personal assistant type app. So I want to update an appointment by ID. What would my route look like?
Put. Maybe like API \route name.
Yep, so we would typically say appointment because that's the resource we're working with. And then what would we do here?
To-do.update.
Well, this is different resource, right?
So appointment dot update. Could you put a by ID on that?
Yeah, you could make this by ID. In fact, you would probably want to have an ID for it. And the resulting SQL would be something like update appointments, set, something where ID equals something else. So you're starting to see a pattern with, hey, this is a thing I want to do. Maybe I want to update the text of an appointment. So I send all of that information along. And these are different points on the back end that you can kind of check to make sure that that's happening. And knowing the underlying stuff behind it will help you quite a bit. Let's say that I want to read or get info about a specific, let's say get info about a specific book, meaning I have the ID for it. What would that be?
Get.
So it's a GET request.
API books ID.
/ book ID.
Find one.
Book.find one, and then it would have where ID is rec.params.id, like that. But we're not going to write all of that out. But for the chart, and then what would the resulting SQL be?
Select.
Select from.
Select, yeah.
From
Books.
books.
Where ID.
Your ID.
Equals whatever they passed into us, right? So what we want you to get to is the point where I can give you this. Hey, go ahead and make a new to do, and you know, oh, that's the chain of events that'll happen on the back end. Or, hey, we need to update an appointment with some new info, and you will know, oh, okay. That ends up with this. When I want to get info about a specific book, oh, it's going to be this. And these are some pretty base things. They're only using one model. We're not putting information together for any of these. They're relatively independent from each other, but this is a place you want to be able to get where you kind of can translate something and this more like, hey, this looks like something that you might think of, hey, we need to do this so that the user can insert new to-dos. We have our front end, we designed out a form for that, now what? And so the backend team can know about, hey, these are the capabilities that we're going to need based off of what the front end team describes what they need to do. Or based off of what the user story says that they need to do. And then once these routes are established, if you have those in place, then the front end team can go, oh, okay, I'll make it so that it's ready to call from those when needed. And in the meantime, I'll just work with some hard-coded values, and then we can switch it over eventually. And having a model in place can help you keep the names the same, etc. Cool. So setting all of this up can sometimes be a little tricky. And we're going to show you a way that you can help speed that up by doing some code generation with some tools called Sequelize CLI. I'll go ahead and copy all of this into, let's see, I'll put that in resources because I have something else I'm going to post in class activities pretty soon. So go ahead with me and we're going to do this next piece together. So right here I've got a server.js. It doesn't really do anything yet. This might just be how you started out. You've got a package.json and it has npm in it, etc. Let me just posted some stuff in class activities, and we're going to go through how we can start making this work. It references 2 external pieces of documentation. The first one is the instructions for how to follow this. The instructions are a little outdated, so I've also included some substitute steps to work on there as well. So let's get started with that. So right click, open in terminal. The first thing that we're going to do is we're going to install some dependencies. One of those dependencies is obviously Sequelize itself. And that one we're going to install like normal by running npm install Sequelize. The next one is a little bit different, where we're going to say npm install -- save dev Sequelize CLI. Now this is a developer dependency, meaning to run the project, when we deploy it to Heroku or something like that, this isn't strictly necessary, but it's going to be helpful for us as we work on the project. The same way that you don't run your tests during with the live server, but you want that as part of your test suite to make sure that while you're building it, everything still works, things like that. And Sequelize CLI does a lot of stuff. We're going to just look at 2 small different things that it can do for us. And then if you want to learn more, you can look into it or ask me more during office hours.
Was it Sequelize dash CLI or space?
Dash CLI. If you look in Slack, it'll have the exact commands for you.
Sorry.
No worries. The next thing that we want to do is we want to make sure that we initialize everything. So the first thing we're going to do is set up our connection criteria, just like we've done in the past when we're talking with the MySQL package, etc. In fact, we should make sure we have MySQL2 in here. So I'm going to say npm install MySQL2, and there's on that. And then I'm going to add that into the instructions on Slack really quick. There we go. Once that's done, we've installed all the packages we need, and we're going to use npx, not npm, npx to invoke them, to use them. So we're going to say npx Sequelize, and then we're going to tell it specifically what we want it to do. We're going to start out with init:config. What this will do is it will make a new config folder for us. And just like we used to use that to manage our connection, we're going to have something similar. So if you look in here at config.json, this sort of sets up 3 distinct environments for us. The first one is for your local development environment. The second one is for any tests that you might run. And then the third one is for production. Later, we're going to learn how we can substitute these out for environment variables so that we're not doing things like putting in our production keys in GitHub and stuff like that. So we'll take a look at environment variables and how we can use them so that we don't just hard code our password into our GitHub repos for our production databases. Not always the best idea. So once we have that in place, we're going to make a folder that leverages all of that. And we're going to name that folder models, and Sequelize CLI is going to do that for us. So we say npx Sequelize init:models. And this will make a new folder for us called models, and inside is a index.js. Now, this index.js is a bit more complicated than the index.js we've used in the past, but its purpose is largely the same, to group together a bunch of models. But what it's going to do as well is handle the relationships between each other. So if I need to define that a Sequelize model, let's say that we have books and authors, if I want to connect the 2 together so that the author and the book are related and that the Sequelize models know about that, then they'll need to be associated with each other. The index is going to handle that. And it's also going to handle syncing all of them to the database so that we don't need to manually do that. So if we look at index.js, it first blush looks kind of crazy. But this is largely built out of pieces that you've worked with before. You've worked with the FS module, you've worked with the path module, you've worked with the Sequelize module before. This is just checking what environment this is. This is just loading in the correct JSON. This is just an empty database variable. And so what this does is it asks if you're using an environment variable or not. And then it initializes Sequelize one way or another. Then this looks for all of the different files within the models folder, which means you should only have things that are written in a specific way in the models folder, because this index.js is going to look through all of them. It's going to look through all of them and grab all of their data. So it goes through and it's going to look for all those other ones, and then it builds a list of db.todo, db.appointment, db.whatever, and exports that along with 2 other values, our connection and the library itself. Now let's go ahead and make a model together as well to sort of just show how this works. So I'm going to click on the instructions in the PDF. I provided an updated version for the first few steps. For 1 and 2, of course, we'll need to make sure that our database is connected, things like that. So you will need to make sure that you have a database here. Let's call it, let's just say that we have one called database development. I'll set this to be DB password, and I'll just make a new one in my workbench real quick. Or you could make a completely new one, just make sure that you update it here in the config. So I'm going to create database development. If it already exists, I'll just drop it, but I think I have that's name free. Awesome. This is just so that Sequelize can connect to it. I've got my username and password set up, my host. I've told it that it's MySQL. And now I'm going to make a new file right here. And the example that we have here is a user module. What does the user look like? Well, the user has an email and a password. Later, we'll be talking about how we can make this a little bit more secure than just storing their password in plain text and then checking if they happen to be the same thing. But let's just start with that for now. So I'm going to make a new file and I'm going to name it user.js. Do they want it to be uppercase or lowercase? It doesn't matter too much. Yeah, lowercase, that's what I thought. Rename that to be user. Now, so instead of us just returning an object, what we're actually going to return is a function. And this is the function that's used to create the object. In the same way that we had return functions that would be used to create the views where it would just return a string afterwards, we're going to do the same thing here. So we'll say module.exports is equal to a function. Now that function needs to take in two things. It needs to take in a connection to the database, that's the lowercase Sequelize, and the different types of data. Going to be very similar other than that. So I'm going to say Sequelize and data types. Now, from here, it's going to look very similar, where we're going to say, all right, const user equals new or equals Sequelize dot define, and then it's very important to make sure that you keep this name the same. This user right here doesn't really matter. That one's just what we're referencing it as locally. What other things are going to be referencing it as is what is written over here in this string. So you could call this one what about a bing bong if you wanted to, but you should always call this what you want other values to reference it as. So in our case, we're going to use the word user. Now, after that, it looks pretty similar where we just pass an object with it, except instead of saying Sequelize.string, we're saying data types.string. If you want to name it Sequelize, you could, but it doesn't have the full Sequelize library in it, so it's sometimes a bit better to just write it as data types. So we'll define this user. We'll give them an email, which is just a string. And then we're going to return that user. So rather than writing out the user module and just exporting the module, we're exporting a function used to create it. Because what we're going to do in our index is if we come down here, should be on here somewhere. Oh yeah. What we're going to do inside of our server is now sync all of our different models. In fact, if you look in the instructions, if you scroll down here to the next part, syncing our models, you'll see that we try and sync the whole database at once by saying db.sequelize.sync rather than setting up each model to be synced to the database individually. So we're going to go db after we import it. Let's see, put that up at the var db equals require /models, just like we did for views, so that it requires the index.js file. And then we're going to say db.sequelize.sync. And then once that's done, since it's a promise, we then start listening. So this is going to wait to start the database or start the server until after we have, I guess, sunk, after we have said, okay, I'm going to say it this way. First we sync the database and then we start the web server afterward, rather than trying to guess at the grammar of that. My wife taught English for many years, and I'm sure she'd provide the right answer to me. Cool. So now, anywhere else in my program, if I want something to happen, I'm just going to change these to const real quick. I can just say db.user.whatever I want, find all. I don't have to manually import each one of them. Whenever I add a new model, it's just available on this db object, and it's already synced to the database, and it will already have all of its associations with other models set up, which is why we do this. Now, in this opening model, or in this opening set of instructions, we just have one. We just have one, so you're not seeing quite as much why we're doing it, but we'll look at that more, especially when we start associating data with the database. Cool. And again, there's the instructions there. If you want additional instructions, I've also linked the Sequelize documentation, or the Sequelize CLI documentation, so you can see all that it does. But we're going to be using this quite a bit as we go throughout our projects. A lot of the times, that'll already be done for you, or we'll be explicitly asking you to do it. Cool. So I'm going to show you real quick what we're going to learn about what we're going to be building towards today. Oh, is this the class repo? Yes. All right. I need my other repo really quick. With the solved version on it. So what we're going to be doing is building a to-do list. So make sure that we have everything. Make sure that the database exists. That's just what the schema is there for. Again, you don't have to do these steps. I'm just doing this so that we can demo the final result. All right. Give me just 1 second while I update the config on this. Config.json. There we go. All right, so let's go visit localhost 8080. And we've got a to-do app. So let's add a to-do. Learn Sequelize. Add it to my to-do list. So already, just from what we've learned already, when I click add to-do, what route do I hit? What's the method? What's the URL?
Post.
Post. And what will be my URL?
API to do.
API to do. When I click on here and I say learn Sequelize better, and then I hit enter, what route am I hitting?
Put.
Put, and then what's my URL going to be?
To do, and then ID.
ID.
Yeah, /API/to-dos, or /to-do/ID. What about when I click on the check mark button to mark it as done?
Is that
Put route as well.
Yeah, same one. Same one. What about when I click on this X to get rid of it?
delete?
Yeah.
Or destroy.
Yeah. Well, delete, and which will correspondingly call the destroy on the model. So already just looking at this and looking at the interactions that we have, we can already tell a little bit about what our backend should look like just from looking at what the UI is doing and what's happening. We can start to see, oh, this is the path that all of that should happen by just looking at the information. Now, sometimes in the real world, it'll get more complicated. When you add something, you're actually going to be adding a bunch of different things at once. Because what looks like one thing to the user is actually going to be multiple tables in the database. But it's always good to sort of think about, hey, what's our API probably going to look like? Can we arrange it in this RESTful way? And so that's a demo of all the functionality. It's stored in a database. So if I say, hello world, add it to my to-do list, mark it as done, I'll still have it on there if I refresh the page. And that's not local storage or anything. That's just being stored in the database. So we have something that starts out that way. And the first thing that we want to do is we want to take an old custom ORM and we want to replace it with Sequelize. So you can do that by figuring out what the methods are by looking at the SQL that they use. That's one of the reasons it's good to know the SQL behind the Sequelize. So if we look in here, we can see we've got this old connection.js connecting to it in this older way using MySQL. We've got this custom ORM called get to do's, delete to do, add to do, edit to do, etc. And if we look in our schema, it tells us, hey, here's a to-do list. So what you'll be doing in this case is thinking, okay, how do I set this up? What are the different parts of the to-do that I need to make? And then you'll also have your front end, which is pretty much done at this point. Your front end is basically the same. And in the schema, interesting, they didn't include the definition in there. Oh. And then inside of the server, you'll see that we've delegated all of this controls over to the API routes. If we look inside of the API routes, you can see we've got ORM get to do's, ORM add to do, ORM delete to do, etc. Our first step is just going to be converting over what we have to use the model. We just want to use the model at the beginning. So don't worry about getting all of this done at once. The first excuse me, the first 25 minutes we're going to spend on this. We just want to get rid of the old ORM and make the Sequelize model. We're not going to worry about replacing all of these routes with the create read parts, the update delete parts. we just want you to begin with the model. So using Sequelize CLI, you're going to get rid of the old config folder. You're going to make the new config folder with the config.json inside. You're going to make the new models folder with the auto-generated index.js, and then you're going to make the model for the to-do itself based off of what you see there already. We're going to open up the breakout rooms at this point, and if you have any questions along the way, let us know. We'd love to help you out. Good luck. Alrighty, folks, looks like most everyone's piled back in at this point. So we're going to go ahead and go through it. The first steps are just to eliminate what was there previously. So we're getting rid of the stuff that we're no longer going to use, and then we're going to put in our models, and then in sections 8 and 9, we're going to hook that model into our controller so that we can have the routes that call the appropriate methods. So with this connection and ORM right here, we're actually going to not do it this particular way. We might keep this for reference. If you wanted to do something like that, what I would do is just rename this old config. So you have a reference to it if you wanted to hold on to it. And we're not going to update the imports for it. So that's just there. Next, we're going to be on the command line. And we're going to have a number of things that we need to do. The first thing is to add Sequelize and MySQL2 to the project. So npm install Sequelize MySQL2. These are regular dependencies. These pieces of code will be run when we're running the project, when our web server is active and running. So that's what separates it from the dev dependencies like Sequelize CLI. Sequelize CLI will not be running when we have our web server up and deployed, for example. But it's going to help us generate the project. It's going to help the project work better, which is why we have it as a developer dependency. Next, we'll be using npx. npx is known as a task runner. You don't even have to have the package downloaded if you don't want. You can use npx, grab it, and then it'll go up to the registry, download enough of it to use it, run the command you asked it to, and then it's done. Since we might potentially use it more and more per project, and it's also a helpful thing to have, we're just going to include it as a dev dependency here. So we're going to say npx Sequelize, and then we're going to say init config. This will make a new config folder. And then we're going to do the same thing for the models. npx Sequelize init models. I'm actually going to go ahead and delete the old config at this point, as the ORM is pretty well named for us to move forward, and those will be in separate projects. So in here, we're going to make a new file. We're going to call it what?
todo.js.
todo.js. That'll be the name that we work with. We're going to then export not an object, but a what?
Function.
But a function that takes in the Sequelize connection, which we'll make sure that we have set up correctly in just a second. Const to do equals Sequelize.define, and we're going to use it as uppercase. This is the db dot, whatever this name is here, is how you'll call it somewhere else. So it'll be db dot whatever you wrote here. Whenever you need to reference this in another file, it'll be this name. This name is just what we're using in here. Now, the ID automatically gets taken care of for us, along with the timestamps, the created at, the modified at pieces. So we're going to set the text to be data types dot string, and complete would be what data type?
Boolean.
Boolean.
Data types dot Boolean.
Do we have to set a default for this?
No. You can if you want to.
What does as in the literature it says it defaults to tiny_int_1.
Mm-hmm.
So
tiny_int_1 just means that in the database it's stored as a bit, 0 or 1. 0 is false, 1 is true. So you could force it to be a different type if you wanted, but there's no reason for us to do that.
Okay. And like if you want it to start as false, is it always going to default to 0?
Right. So if we said like type data types dot Boolean, and then we said default, I forget if it's default value. I'd have to look up the documentation on this one again. You would say like, I think it's default value because default is technically a keyword.
Yeah, it is.
It would be false, and then so you would see it in the database as a tiny int 0. If it was true, it would be a tiny int. Well, it's a tiny int 1. 1 just describes how many bits are there for it. So it's just the value's always going to be 0 or 1. It's just how it represents it in the database.
Thank you.
So we'll just say by default, the task is always false whenever you make a new one, let's say. Seems like a reasonable assumption there. Not necessary though. If you don't include that part, it's fine. The next thing that we want to do is we want to make sure that this is set up properly. So we want to put the password in for that. And we want to use the same database as before. So we're going to change where it says database development to say to-do list. We're going to change our password to be whatever your database password happens to be. Cool. Now, we're not quite done. What's the last thing we have to do?
Make sure we
Require
sync.
models.
Yeah, we have to require our models. So we'll come up here. We'll say const db equals require /models. And then what?
And then DB, or make sure we sync it before we start our server.
Mm-hmm. assuming that that all works out, we'll do it like this. Once our database is synced, then the web server starts and we're good to go. So let's try this out. The way that we can verify that this works is if we start the server, even though none of our routes are set up to handle that, it should sync the database, which means we should see the database table in our to-do list database. So let's run the schema really quick, just to make sure that we've gotten rid of anything else that happens to have been there in the past. And let's double check everything else. That looks good. When we're requiring that and running that, I want to make sure that we don't have any old references to the ORM. We still do. Let's get rid of those. I'm going to just put res.json there. We'll just say res.status 500.end. Basically, we're just going to say for the rest of these, oh, it's not working right now. Oh, that's the wrong thing. Fortunately, it already exists. So let's run node server.js. Let's verify first in here that the to-do list doesn't have any tables, which we can see there. Let's start up the server. And even though basically none of the routes work at this point, you should be able to verify. Let's see, refresh all. But now we have a to-dos schema. And if we look at the list of columns, it should have all of the different pieces that we specified and then the defaults that it throws in for free. Cool. So you can see that this is a tiny int1, and then the default value is 0, which is what happens when you set a Boolean with a default value of false. So it'll just represent that as a tiny int 0 in your database. Cool. Questions?
Yeah, can you go back to the server.js? I think it's saying that my models, it's not finding my models. Huh. Interesting. Okay, I'll figure it out. Thank you.
No worries. So we weren't worried about in this section making sure that the routes worked. If you finished early, you could have proceeded onto that, but we want to do that in this next section. So if you look at 08, create, read, unsolved, basically this is the solution to the previous activity. This is, we start from there. So if you were able to get it, you could technically continue from 07, or you could just go work with 08. If you look in the package.json, you'll see that we have our Sequelize dependencies here. We don't have the Sequelize CLI dev dependency listed in this particular one, but fortunately, you're not going to need it. So we put it there so you could just npm install and keep going. As our config and our models already exist. So we don't need the CLI to run on the command line and create these different sections. So what we want you to do at this section is handle, create, and read. So by the time this is done, on the web page, let me go back to by the time this part is done, you're going to have 2 of the 4 actions done. where we can add a new entry, and we can see the entries that are already there, but the updating the text, the marking it as done, the deleting it, that part won't work yet. We're just asking you to essentially make it so that when you add a to-do, it adds it, and then when you load the page, everything's visible. So we're just working on that part first here. So if you look inside of the routes here, we've gotten rid of all of the ORM stuff. You could refer to the previous exercise if you want to still reference that stuff, but you're just going to be working on these two routes right here. If you finish early, feel free to jump ahead to the rest of it, but we want you to have this work properly with the front end. The front end is there. You can look in index.html. It's all one page. And then look in JS, view.js, keeping an eye out for, hey, what things do I want to listen for? What events am I listening for? What are the different things that are happening? You can look at your front end to help you with that. But your goal, again, is just to fill out these two routes. If you have questions, let us know. We'd be more than happy to help you out. Good luck. We're still waiting for everyone to pile back in at this point. But once everyone's here, we're going to go through and just add in the relevant pieces. Hopefully you were able to do it. If not, we'll have time for questions after we go through it, where you'll be able to hopefully clear up anything that you were curious about. Cool. So let's go ahead and start the web server. Let me make sure that the config is set up correctly here. I suspect it is not. Need to change the password on there. Restart, reconnected to the database, good to go. Awesome. So if we visit the website as is right now, it'll have nothing on it. We can type stuff and go things like hello, add to do, but it doesn't save, nothing happens. So it doesn't quite work like we want. So to do that, we need to have our create and read routes functional. So let's go ahead and jump into that. So inside of API get API to-dos, this is just going to be our read route. We have a few in the database. We just want to see if that part works so that we can see the ones we added earlier. What do I write? Let me go ahead and pick someone here from the list. Adeji, could you help us out here in our get route for API to-dos?
So I put db.create.
.create?
Oh, sorry, wrong one. Find all, sorry.
Yeah, db.todo. find all, then what?
And I was stuck after that. I wasn't sure.
No worries. Pick someone to help you out.
Matt.
Me, Matt?
Yes.
We got more than
Awesome.
one Matts.
Yeah. So it's find all with the curly braces inside, and then dot then function or arrow function, whatever. DB to do. And then I add, and then res.json DB to do.
DB to do. Cool. So what do? We're just looking for what we have from the database, and then we take all of those items. This is probably better written as DB to-dos because it's going to be an array of them because we're using find all. And then it gives it back to us. So if I refresh the page, now my items are appearing on the page. Cool. We could even have shortened this further, but this works just fine. All right, Matt, go ahead and pick someone to help us work on post right here.
Or Omar, sorry.
Omar, go ahead and start us off. What comes next?
So for posts, it would just be db.todo.create. And then you can just do open and it would just be text : rec body text, comma, complete rec body complete.
Anything else?
Then results are passed res.json results.
Cool. Let's try it out. So at this point, we should be able to add in a new entry. Let's add in there eat lunch. Add to do. Excellent. Now, unfortunately, if I say eat lunch and I want to be extra enthusiastic about it, doesn't work. If I want to mark it as done, doesn't work. If I want to delete it, doesn't work. In fact, we can open up the network tab in the inspector. And if I click on XHR, click on checkmark, you can see that I have a pending request to to-dos. A pending request. And so it's not coming back yet. I'm sending all of this form data. It's actually a put request if you break it out even more, but it's not getting a response. So sometimes if you're worried about this, you can even just say res.send or res.status 500 .end, or I like to send not implemented yet or work in progress, just as a little reminder to myself or someone else, hey, I'm working on this route, it's not done yet. So then when I click the check mark, refresh it again. If I click on the check mark, it gives me back a 500, and that 500 says, hey, we have an internal service error, and if I click on the preview, it just says not implemented yet. So it's very easy for the rest of my team to know, hey, I haven't gotten to this yet, if it's part of my project and I'm working on it. Or for me, when I forget. Cool. So what we're going to do for the next piece, we're going to open it up for the breakout rooms until 12 o'clock. We'll announce, hey, it's break. When we come back, we'll let you continue to work in your breakout rooms on update and delete, and then we'll have some more content to look at after that, looking at things like validations. How can I make sure that they don't try and add in an empty to-do? like that. We don't want them to be able to do things like that. So we'll fix that more in the future. But for now, we're going to move on to the next section. You can continue on in this one if you want, or if you got stuck, you can look at 09 unsolved, and it will have everything in place. You just need to run npm install and update your database password, and then you can run it. But if you look in the API routes, what we did for create is already there. What we did for read is already there. We just want you to fill in, delete, and update. If you're happy with where you are in 08, you can just continue working in 08. If you want to get a fresh start where everything else has been done for you so far, you can start with 09. Any questions before we get started? Right on. If you have questions, let us know. We'd be more than happy to help. Good luck.
So you too, huh?
Yeah, I didn't know if we were still supposed to be in the breakout room. I know sometimes they just like, they'll gather everybody, but I sent Larkin a let's see. Okay, yeah, we'll be starting pretty soon.
Okay, yeah, I think it happened to everybody because Elliot got kicked out, and I saw you were gone, so I checked to see if it was pulling us back into the break rooms, and you left early. So I just left the break room, and now it's just you and me. So
yeah, I got nervous because it was 12:45, and I was like, I'm here. She just asked if we can, let's see, join breakout room. Yeah, so if you go down to the bottom part, it says join breakout room.
yeah.
Alrighty, folks. Looks like everyone's back at this point. So what we're going to do is add in some things for update and delete. I'm going to just be continuing our work of 08, but you would do the same thing if you were using 09 in this particular case. So in this, we're just finishing out our actions. We're just finishing out being able to work with the rest of the CRUD actions. And after this, we'll look at some validations and other pieces like that, which should be pretty fun. So the only file we're going to need to change is our API routes, as our front end already supports everything that we're currently doing. So let's start out with, which one do y'all want to start out with, deleting or updating?
Updating.
Deleting.
All right, I heard updating first, so we're going to go updating. So let's start with updating, then we'll go deleting. So we'll start out with db.todo. And since we're updating, what's the corresponding Sequelize method?
Update.
Update. And so we're going to be updating some specific things like the text. Because this is a put request, we know that the front end, by convention, should be submitting everything that needs to get updated, not just a piece of it. We don't have to piecemeal pick the pieces that we want to update. We know that we're going to have the whole thing. So we'll mark both. Now, with update is going to be one of the few of these that take two, because it needs to know what am I updating, like when I do create, like, hey, this is it's the values that are getting updated, but then we need a where clause, like we do with the finds some of the time. So we need to update it under some certain conditions. So we're going to pass another object. And in that object, we're going to say where ID is equal to, well, the body of the ID. Remember, the to-do is passing us a whole copy of it. So while you could, by convention, say /:ID or something like that, the fact that it's already sending us everything, because it's a put request, means we can just get it from the body of the request. Once that's done, then we'll just send back our response. So we'll say then db to do res.json db to do, and we'll call it good at that point. We could even throw in a catch if we were worried about it. So that's our update. Let's check that it works. Let's go back to our page on localhost 8080. So let's mark eat lunch is done. Let's try and add a new entry, add an old entry. And if I refresh the page, they stay that way. However, delete button, still a work in progress. So we come up on one of my favorite methods. It's going to be db.todo.what?
Destroy.
Destroy. Just picture it blowing up somewhere in a giant explosion, which I like. I feel like that was me growing up watching Mythbusters a lot, gave me a love of explosions. So we obviously don't want to destroy everything from this route. We just want to destroy the one specified. How do I do that? What else do I need to put in here?
So destroy where,
Where?
and then an object, and then ID : rec.params.id.
Right. Now we remember that the three methods that we have bodies are post, put, patch, the three P's. If it has a P at the front, it has a body. Delete requests, get requests that do not. So we have to use the params to pass that information along. So once that's done, then we'll take the information that we get back from the database, and we'll send that back to the front end. This will just have all the results about how that works. We'll come back here. Let's get rid of this empty one. Let's get rid of all the ones that are done. Let's refresh the page, and it looks like everything still works. Now, the user can use this at this point. In some sense, it's at an MVP, but there's a lot of quality of life improvements, we might call them. Things that aren't necessarily essential to the task, but just make using the app more pleasant. One of the easiest ones of those is we shouldn't allow them to make blank to-dos. Not only does it break our formatting, it's not especially helpful to the user. So we want to make sure that we don't allow that. And that's what we're going to do next with Sequelize validations. Now in Sequelize validations, you're going to be making changes primarily to the model, but then you're going to also want to catch when certain things happen, like when something fails from a validation. So we can't just say .then for more of these. We're going to need to provide other information for them. So if we look in our models to do, what we're going to need to do is expand these at the very least to say type, data types string, like so. And then what we're going to need to do is to add some validations to it. So we're going to leave that up to you as part of this exercise, but we will direct you towards some resources for it. So for this one, I might say something like validate, and then I'll have an object, and then that object will tell me some stuff about it. Earlier in the course, we referenced allow null. We might say like, hey, this can't be null. By default, it can be. So what are some of the rules we might have there? Let's say that the length of the to-do has to be between 1 and 140 characters. So what you'll need to do is to look in the documentation and say, how do I say that? How can I make sure that that's the case? For the fact that this is complete, we looked a little bit earlier at the default value. How can I make sure that complete will have a default value of false? Other pieces like that. And then how in my routes can I handle if something goes wrong? When we wrote them last time, we just had .thens, assuming that our promises would get resolved. If the validation fails, the promise isn't resolved, it's rejected. So you're going to need to put pieces into the route for that as well. You can continue working from 08 or 09 if you're feeling confident with your answers there, or if you want just a fresh start where everything's already in place, you can start from exercise 10. In terms of looking at the documentation, again, we're working with version 4, sequelizejs.com. If you take a look at version 4, and then there should be a spot in here for that. Let's see, model definition, validations, and this will help you learn more about, hey, how do I specify some of the rules for this model beyond just what the data type is, etc. Any questions before we open this up? Right on. I'm going to post this link in class activities. And we're going to open up the breakout rooms at this point. If you have any questions, please let us know. We're going to work on this activity for the next 15 minutes. Good luck. Alrighty, folks. We're going to get started with some Sequelize validations here in just a second. After that, we're going to look at some stuff that is unique to logins and security. We want to be able to have users who can be able to, whenever they do something, we want it to be associated with an account they have. And to do that, we have to know what user accounts look like. Now, on Monday of next week, we'll look at how we can build these models together, the kind of things where you would associate things back and forth with each other so that you could do joins and other stuff like that. But for right now, we just kind of want to look at, hey, a user model by itself, what would it look like? If we have a user model by itself, what would it look like? That's what we'll look at next after this. And we'll also use that as a way to slowly say, hey, starting from pretty much scratch, how do we move forward building a web application? So we'll be doing that with the last hour of class today. So, but before we do that, let's do this. Now, if we look back at the documentation that we had earlier, so I'm going to grab the link that I slacked out earlier. Let's look at some of the different validations. So we can go through here. One that we might look at is length. Allow values with a length between 2 and 10. We want to do that with 1 and 140. You can even do extra stuff on here, like writing functions to check if things are true or not, but we're just going to go with some of the defaults. Another thing that you might have on here is whether something is allowed to be null or not, but that's technically not a validation, but that's down here. So if you allow null, then it's that happens at the database level, but the validations all happen at a JavaScript level. So if you alter the database, or if you go through the workbench and alter the data so that the data is invalid, it's not going to be prevented from doing that, versus like allow null. That's a thing that you can set up on the database. So you can still go behind the scenes and change it using the workbench so that it doesn't match the validation. The validation that we set up with Sequelize only affects it as it's traveling through the Sequelize model. It won't if you go directly to the table underneath it. So just a quick note on that. Let's start with our text. So for text, we want to make this mandatory. So we're going to say allow null false so that it has to be there. You can't submit something without text. However, this still allows the users to submit empty string. Empty string is not null, but it's not useful in this context either. We want it to at least be 1 letter long. So we're going to add in a key here that has to do with all of our validation rules. And that key is called validate. It's an object, and we're going to say that the length has to be between 1 and 140 characters. Between 1 and 140 characters. Now, for complete, we're going to start out similarly, except it's not going to be a validation rule, it's just going to make the default be false. And the default value will be false. So let's just run this here. Let's try and enter something invalid and see what happens. So we go visit localhost. '80, and I try and add something wrong, and look here in our web server, we blew everything up. Just get a Planet of the Apes vibe whenever I say that. So the validation failed. So what did it do? It threw an exception. The promise of creating this new entry got rejected, and our software didn't handle that correctly. So what we need, rather than making the server blow up at this point, we need to gracefully handle errors. It's very important that we gracefully handle errors so that our web server continues to work even if people do things that are invalid. Fortunately, it's not that much extra work. we're going to specifically come to the update and post routes, things where they're sending us new information that can potentially fail the validation. And we're going to add catch statements to them. So I'm going to say .catch. If there's an error, res.json error. We're done. Not a lot more to it. We're pushing off the responsibility for handling all that or displaying all of that to the front end. So we'll just put those around there. Now, if we were being extra careful, we'd have that around the gets to. So let's say that the connection to the database times out. We still want to be able to say, hey, here's the error. So nothing wrong with adding that on here too. In fact, you'll have something like this on most of your routes. So that you can say, hey, if there's an error, we want to catch that error so it doesn't crash the whole web server. So that if someone puts in a bad information, it doesn't take down the whole server. It just says, yeah, here it is, and here's the error message that we give back to you. So now if I refresh the page, make sure I saved everything here. If we scroll down to the bottom, we can see that it starts the server back up. Everything looks good. And now if I click on add a blank to do, it notes that it tries, but nothing kills the server. Server's still alive. And if I look at my network, and I click add to do here, you can see that I get back, let's see, it should be in the list here. That's the get. This post request got back a 200, which just has, hey, here's the errors. We still sent back a response. We've got what you wanted. We might send back some other error, like, hey, there's status codes that you can use to say, like, I think it's 422 would be like unprocessable entity, which would be like, hey, this isn't correct. You're sending us things that don't work. But that's a way to handle all of that. So now we have a nice little message that the validation failed. And if we even look, we can look at more details about why it failed and then present a nicer example to the user of, hey, this has to have at least one character, no more than 140, etc. Cool. Any questions about validations so far?
On your todos.js file, we had found and used the not null equals true. Is there a difference in that with the allow null false?
So let's see, not null, true. So this is the difference between this is going to have JavaScript enforce that it's not null. So when it comes to the model, it won't be null. Versus allow null is going to be a little bit different. Allow null sets it at the database level where it won't allow that column to be null. So it just depends on how you're setting it up. But they do similar things. It's just, are you checking in the JavaScript or are you enforcing it at a database level? So if it fails the validation at the JavaScript level, you don't need to even talk to the database because you're saying this isn't valid, throw it out, which can be nice. So you could put both. You could put both, and that there's a use case for that, and because it would fail it out earlier. And then if you tried to modify it directly using the workbench, it would also fail because of the allow null rule. So if you use not null there, that's fine. It's just enforcing it at two different levels, either at the model level or at the table level.
Is that the same thing with putting in the validate and having a length attribute opposed to just having a min 1 max 140?
So this has to do, when you say min and max, that has to do with numerical values more than the length of a string. So this would say, hey, if I want a number and I want that number to be only between 1 and 5. For it's like, how many stars did you give this? It's between 1 and 5. And if they gave, say, 7 stars, we're not going to allow that, things like that. So min and max are for making sure. You could even write a custom validator where you could say like is valid string, and you could be like, hey, you could say, hey, what's the length? Does it include at least one vowel or something like that in there? So if none of these match up with what you want to do, you can always write your own custom validation function.
My only other question is was Googling other stuff for validations and came across 2 other articles that had said that if you want a default value for a Boolean, you can't write true or false. You can only do 0 or 1.
Did you check the date on those articles?
I did not.
Okay, that's the thing I would do. Because you can use that. You could use 0 or 1 in there, but you can also just say true or false because it's a Boolean type and it'll translate it to that. Yeah, that's the tricky thing about those things. Yeah, especially if something's like 4 years old, depending on how you do it, they might have implemented differently, or if they're mentioning the specific version of Sequelize they're using, because Sequelize has 6 different versions at this point, and those are major versions. So that would be my guess. And again, try it out. See what happens if you use that model and it doesn't work, etc. And I'm fallible. I might be wrong about that, but I'm 90% sure you can just say true or false. All right, cool. So for this next activity, what I'm essentially going to be doing is walking us through some piece you already have. If you look in 04 supplemental, you'll see this item right here called Sequelize Passport example. Passport is a technology used to help with logins. What we're going to show is a simple login flow for a user where you have their username and password. There's also other types of user flows, for example, authorizing with Google, doing an OAuth flow. That's not what we're going to cover here today. What we're going to do is kind of a pretty simple case where we have a user's name, we have a user's password, or when they sign up, we store those things locally, and then we go from there. And we're going to start from relative scratch. I've already taken the liberty of installing a couple of different packages like Sequelize, Express, MySQL 2. These are all technologies you've used before that I've pre-installed here. And we're going to walk through exactly what we're going to do. So inside of the server, I'm just going to start with a very basic bare bones server. And we're going to come up with a couple of different pages here. I'm going to have signup.html. I'm going to have a login.html, and I am going to have a profile.html. On my sign up page, that's where you sign up. On my login page, that's where you log in. On my profile page, that's where you can see the data about you, the person who signed up, and only you, the person who signed up. We're not going to add in too much more than that, but let's begin with, let's let the user sign up. Let's let the user sign up. If the user can't sign up, can't do a lot else on our website. And maybe we'll make a extra page called public or something in the future. But let's start out with this. I'm just going to say login. I'm going to grab a link to jQuery real quick because we're going to use that. I might even throw in Bootstrap as well really quick. So here's a link to Bootstrap, just the CSS, and here's a link to jQuery. And then we'll put our own script in there. So let's start out with H1, our cool website login. We'll make a form, we'll go ahead and put in a couple of different inputs. It's also good to provide labels for these inputs. So we'll say label. We'll give this one a name equal to email. And we'll give this one a, we'll say for email. And we'll say email, colon, and then here's the input. We'll even give it an ID to make it easy to find. ID equals, we'll just keep the name there. The name is fine. We'll do the same thing for password, except of course we'll change the type to be password as well. And if you were extra careful, you would even have them do a password confirm. We're going to skip that step for now. So this is what my form looks like. If I just look at this in the browser, not a lot going on. We just want the user to be able to sign up with their email and password. So what we're going to do is we're going to make some models, make a web server that can support all of this. So if we're thinking about this, this would mean, okay, I've got post/API/user. This is going to use the user model. It's going to call user.create, which will end up creating a database call that's insert into. So I'm going to use Sequelize to handle this part, and then I'm going to make an express server to handle that part as well so that we can serve both of them. So I've already got Sequelize CLI installed, so I'm going to say npx Sequelize init config, just like we did earlier, and I'm going to do the same thing with models. So inside of my model, I'm going to make a new file. Let's call it user.js. Module.exports equals function, Sequelize, data types, const user equals Sequelize.define, user, and then we're going to have email, which is going to be a type, data types.string, and then let's also include some validations on there. We just saw some of the validations. So let's say it's an email. So it's not going to work unless it qualifies as an email. Now, while you're working on this, you might relax some of those constraints just so that you can type in the letter A and be done. So validate is email true. We'll just keep that one as our validation for now. Next, we're going to need our password as well. For now, I'm just going to leave this as a type, data types.string. Pretty normal so far. Later, we're going to add in some things to help beef up the security, but this is just what our user model looks like right now. It has an ID, an email, a password, and when we learn about how to associate data, a lot of stuff is going to be tied to a user ID. For example, if you're on an e-commerce site, you sign up using as a user, and then your order history is all going to be tied to your user ID, things like that. Any questions so far? Cool, let's make a web server. So we'll say const express equals require express, const app equals require dots equals express, const port equals process.env.port or 8080. And then we're going to say app.listen on port, and we'll also use app.use express.static public. Cool. This is kind of the minimal website you're going to get away with. We aren't even connecting our database at this point, but let's try it out. So let's say nodemon server.js, and I think something else is already listening there. So let me shut that down and whatever other server is doing that. Yeah, this boy right here. Let's get rid of that. So let's visit localhost 8080. Signup.html. There's our page. You'll even see that because we've given it a name and a password, Google Chrome will try and auto-populate it. It'll try and be like, hey, I've saved a username and a password for this site. I'm going to put that in there. But that's your browser doing that. That's not our website telling it to do. That's Chrome trying to be helpful. Cool. So looking at this, what route do I need to make a new user?
Create.
So, well, what route? So
API
what's the
user.
front end going to use?
Or
App dot
API
what?
log.
Post.
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 API /user/new.
We could just say user. Post already tells us it's a new one, because when we post, we're creating something. So we don't necessarily need new. We don't have an ID for them yet. So we can already tell, hey, this should have a user. So even just from that, we can already know, and we could even send back a fake user as a result. We know what the data looks like while we're working on this part, while we're getting our database set up and the rest of it. So we would say the ID is 1, the email is test@test.com. The password, you probably shouldn't be sending back people's passwords, right? Even if along with them. And then you might say created at date.now. And then updated at. To just sort of stand in for the timestamps that you're going to get. Cool, but let's actually, so now if I hit this route, let's say in, or let's actually change this to be rec.body.email, rec.body.password, and then we'll just do that. So let's check our post route with Postman just to make sure it works. And now our front end team can kind of assume that it works. They can code it like it works, even if it's not fully there. While we're waiting for Postman to boot up, we're going to say const db equals require /models, like we did before. And we're going to say db.sequelize.sync. And I'm going to set force true right now because I want it to restart each time I restart the server. We'll have to remember to turn that off later then. We're going to get an error here because we couldn't connect to the SQL database correctly because we haven't updated that part first, right? So we go through and we'll go, okay, what do I name this? Let's name this passport example. Put in my database password. And then let's make a new folder. We'll call it DB. And inside of there, I'm just going to make a new file called schema.sql. And all this is going to do is I'm going to create this in there. I'm going to drop it if it doesn't exist, and then move on. So drop database, if exists, this, create database passport example DB. So it's just there to make that. Let's make sure that this is run in the workbench. Got that new database. Let's go ahead and restart the server. What is it not like? Oh, I renamed it and didn't save the fact that I changed it. There we go. So now it's connected to my database. We can verify that my model is there and working correctly by going to it in the workbench. So we'll refresh this. And then we've got passport example DB right here. We look at tables. We let's look at the table. And we can see the columns for ID, email, password, created at, and updated at. And those are both date times. So now we can kind of take that out of the way. So let's go back to our server. And instead of just sending this back, what are we going to do? db dot what?
Create.
Yeah, db.user.create. And we'll take the email. Or I like to even do it this way, const email password equals rec.body. And then I can just say, hey, go ahead and create it with this email and this password. Then let's take that DB user that we get back and let's just send it to the front end. And then let's say .catch, if there's an error, res.json, whatever that error is. So if they fail the validation, shouldn't work. We can test this quite easily with Postman. So we're going to go localhost :8080/API/login. And I go to the body. I am going to set this up as a raw JSON document where I set the email to be test@asdf.com and the password to be 12345. Cool. So let's send it to my backend and see what happens. And I get back cannot post /API/login, API/user. And it says error, something went wrong. Okay, let's take a look at what. Cannot destructure property email of rec.body as it's undefined. Whenever rec.body is undefined, what does that mean for us? What did we forget?
Did nothing call it?
It did call it, but remember we have a piece of middleware. We've got these two lines right here, and those are what actually populate the body. Those are what delay us handling that request until all the data has come in. If I forget those two lines, I don't have a request body. So it gave us that error, as it should, and the good news is we don't have to bother typing all of that in again. With Postman, we can just send that request again, and then it gives us back everything like, hey, here's the ID, here's the email, here's when all of that stuff was created, etc., etc., etc. So we're good to go on that front. Now the problem is I can send this request a couple of different times, and what might be a little bit weird about this? Like if I come over to users and I look at my list of users, what might be a little weird?
Lots of duplicates.
We're allowing people to sign up with the same email address, right? Not much of a good unique identifier in that case. So what we want to do is put constraints around that. So something that we might do on that page is we're going to go back to our model definition. So inside of our model, we're going to add in some other constraints. One of these is going to be allow null false, so we can't have null users. And another one is we're going to say, please make sure that it's unique. Please make sure that nothing else here has that. So now it's going to violate that constraint. So these, because they're not checked in JavaScript, are now going to we're going to need to refresh the table. We're going to need to force it to run again, but that's fine. Another thing for the password, we should probably say allow null to be false and other things like that. So important constraints that we're uncovering just with Postman and just testing things. So let's, we've restarted the database at this point, and because of force true, we can even come back to our select statement and everything's gone because we resynced the table and we set force to true, so it's always going to drop the table and reopen it again. When do we do that? Later, we'll change that, but we're just working on this model right now. So we're going to click send. Works the first time. Let's click send again. Email must be unique. So we're feeling good at this point. Now let's hook up our front end to it to make sure that that part works. So we'll go over to our front end, which will be inside of our public folder.
Question for you, Eric.
Yeah.
When you have a validation and you have your typeset in when you're making a model, will it throw like unique identifiers for an error so that you can snatch all of them? Like if you have one for making sure it's an email, making sure it's not duplicate, that it's easy to grab those and
yeah, it will send
message?
out an array of all the validation errors that failed when you submitted it. So it's not going to go one at a time. It'll just be like, this is everything wrong with this. So if you don't include a password and you include a duplicate email, you'll get errors for both at the same time.
Okay, thank you.
No worries. So let's go ahead and include some JavaScript on here. And we'll say type equals text JavaScript. And let's say let's add a button here to submit. Hashtag submit dot on click function event dot prevent default. And then we're going to say, like we normally do, go ahead and find the input with the name equal to email and get its value. That's going to be our email. Do the same thing for the password. And then $.post the URL, which will be /API/user, the body, which will be email and password. And then we're going to check what happens in that particular case. We're either going to get back errors or we're not. So let's just look at what we get back. So let's call this response, and we'll console.log out the response. If there's an error, we'll console.log out error and then the error itself. Cool. So let's check this out. So let's try this. ASDF@asdf.com, login. Let's look in our console, see what we got back. Cool. Gave us back this object, which it gave back all of the information. Now, a couple of things. No. We never send people's passwords back to them. Why would we do that? That's bad. So one of the things we might do already is go back and say, okay, we're just going to send you back a message that says success or something like it. But we don't want to ever be sending back passwords, especially unencrypted passwords. But it's successful. That's all right. So let's click sign up again. And now we got this. Here's a list of errors. So let's refactor our route a little bit to account for this. So our server, once we create everything, we're going to make this a little bit more complicated. So we're going to send back a field and I'm going to just say, all right, success, true, it worked, good job. Like that's something that you can do. There's other ways to do this as well. This is just the way I'm choosing to do it right now. So if they sign up and all of that works out, sure. Or we could send back when they try and sign up. Well, actually, let's change it. Let's do it this way. This will be easier. Instead of saying, so we'll say res.json, and what we're going to do is we're going to take out parts of the DB user that we're happy to send back. So we're going to say the email created at, updated at. We're happy sending that back to the user, that's fine. And so we'll send back email created at, and then updated at. For our error, let's change the status so it's no longer a 200. Let's say that this is a 401, which is essentially an unauthorized error. So let's try that again. Let's look at our response, first in Postman. So if I send test@asdf.com, awesome, the password is not getting returned back, just the parts I want. If I click send and it tries to happen again, then I get back this and I can start to determine, okay, what should I do when there's an error in this method, or if it's a different kind of error. So let me double check my notes real quick. All right. So we can see, let's open this up a little bit so we can see more of it. And there should be a field in here that tells us the message. Yeah. And this should now trigger the catch on our website. So let's refresh the page. Let's sign up. Let's sign up. We get back this, we get back an error, and it tells us, for example, the response JSON right here. And we can start accessing some of the different pieces like the list of errors. So let's put a little field on the front end just so that we're communicating that to the user so it just doesn't fail and the user doesn't know why. Let me make sure I'm working with this one. There we go. So on signup.html, I'm going to make a little div afterwards. ID equals response field. And if this is the case, I'm going to say response field dot HTML, a p tag with a class equal to alert success, user created. User with email, response dot email was created. If there was problems, I'm going to say build out this following, and I'm going to say alert error. We'll have another errors encountered. Put a little break tag there. And then I'm going to make a list of all those errors. So it would be error.response json.errors.map. I think that'll do it. So let's try this out. I sign up, and there's my error message. Let's restart our web server so that we've got a clean slate, and let's see if it works correctly. Sign up. Fantastic. It worked. Otherwise, list of problems. And that's a lot of what you want to do with validations. Someone signs up, it works. Someone doesn't sign up, you need to tell them why. You need to tell them why it doesn't work. Now, we're going to talk about any questions about that?
Do the errors that get thrown have unique IDs that you can kind of capture to make specific like error messages rather than just listing them out?
So in this case, if you look at the errors, like the list right here, they'll have a list of everything. So you could be like, you could look at this particular one, and you could look at the type unique violation, and it'll often tell you other things like, hey, what's wrong about it? The fields that made the violation. So the email, in this case, is taken. So you could say, hey, does this have a field called email? If it does, that means that test@asdf.com is taken. So yes, there is a way to essentially decode it. You just have to dive into it a little bit more. And since we're trying to do a bunch at once, we're kind of just doing the minimum to show you what you would want to do. But great question. Other questions? Alrighty. Let's go on to another problem. If you get one thing out of this whole thing we're going through, I want it to be this: never store the user's password in plain text. Never just have a database full of other people's passwords. Just don't do it. Just don't do it. Now the question is, okay, then what do we do? How do we do that? What's our option? And what we're going to need to talk about is the idea of hashing and salting a password. So what does that mean? I like to call it mangling because that's a pretty good description of what you're doing. And the idea behind a mangling process is this. And most security runs on this in some way. This box is your original password. And let's say it's something incredibly secure like Hunter2. You don't want to store Hunter2 in the database. So instead, what you want to do is you want to store something else. And our mangling process here in the middle, which we'll call hashing and salting the password, makes it so that if you have Hunter2 at the beginning, it'll be mangled into something on the other side. But if you mangle it the same way, Hunter2 will always produce this. But it's hard to go back from this to go Hunter2. You want it to be easy to go this direction and hard to go that way. And that's what hashing functions do, is it's very easy to go this direction where we take Hunter2 and we mangle it. And this is what Hunter2 is once you mangle it. And it's very hard to look at this and go, oh, that's Hunter2, and have a computer go the other direction. And what we're going to do is whenever we ask for the password, we're not going to store the password, we're going to store the mangled results. And then when someone comes along and they say, hey, I've got a password for you, if it's the wrong password, let's say that it's something like secure, that's going to get mangled into something else. And it won't match. And so we can say, okay, this got mangled in the same way, these two don't match, so the originals can't be the same. And that's what we do with passwords. We make sure that that if this is Hunter2, it'll mangle to this. It'll get hashed into this. If it's secure or any other password, Hunter3 even, it won't. And so we store this and then make sure that the process of mangling that works the same. Now, to do that mangling for us, don't write your own. Use other people's who have written much better algorithms for doing this. We're going to be using a library called bcrypt.js. So I'm going to say npm install bcrypt.js. And then I'm going to make some changes to when I store my password. So we're going to go look at our model again. And we're going to add a special method to my model. I'm going to say user.addHook before create. This you might think of as an event handler. And what this is doing is, hey, when you make a new user, before you insert them into the database, run this function first. This is going to be what was given to us as the user. And what we're going to do is we're going to mangle the password here. So let's load in bcrypt, which we just finished installing. And now let's mangle the password. So we're going to do this in a way that there's two ways you can do this, synchronously and asynchronously. It's better to do this sort of stuff synchronously, but that's going to have us working on it a bit. So we're going to say bcrypt, and the first thing we're going to do is something called generating salt. So I'm going to say that we should take 12 rounds, and once that's done, I'm going to get some salt back. In fact, if I just say, let's go here, node const bcrypt equals require bcrypt.js, bcrypt.gen salt, sync 10, that's salt. What is it? It's a random string of some kind. Why would we include that? The answer is because of attacks on databases called rainbow attacks. You know that a lot of people use Hunter2 for their passwords. You also happen to know our hashing algorithm for some reason. And so what you do, or maybe you don't even know what it is, but you can guess a little bit because as it turns out, some people use the same password. How many people use the word password as password? More than there should be, right? And so what you can do is if you know the hashing algorithm, is you can just run, I don't know, a list of the 100 most common passwords and see what matches. If you somehow get into the database. We don't want that. So what we're going to do is we're going to say our password is Hunter2 plus something. That something is the salt. And that means that if you have Hunter2 and I have Hunter2, we're going to have different salt. And so we're going to have different mangled up passwords. So even if our passwords are the same, they won't be mangled to be the exact same thing, which is why it's very important to have salt in a database. So we're going to generate that salt. As you can see, each time we run this, it is a new unique number. It's generating something new each time. So we're going to take that salt and we're going to add it into our password. Fortunately, bcrypt handles this for us. So we can just say bcrypt.hash and let me make sure I'm doing this correctly. Let's see. I need to look up the user before thing here in just a second here, but bcrypt hash, what was the password? Well, that will be our user dot password, and then it's also going to ask for the salt that we just generated. Now the salt is going to be stored in such a way that the salt is just there. It's just part of the string right at the beginning. Let's see. Before hook user. Let's see, it would be return and then return this. And then we would say dot then. We'll call that our hash. User.password equals the hash. All right. So let's make sure that this is working correctly. We're generating some salt. I think the minimum is 12. I'd have to look it up. Basically, I look up how many minimum salt rounds you should go through. The more salt rounds you go through, the more computationally expensive it is to generate the salt, but also the harder it is to unmangle correspondingly. So let's start up the server again. And now let's sign up again and see what we get as our password. So I'm going to send this. There's my email, created at, updated at. So I just sent this. And if it worked correctly in my server, oops, don't want that. I run this, and here is the new password. Now, some of this you might remember looks kind of similar to the salt, and part of this is the salt itself so that it can check and do the math to make sure that it works, but part of this is just my mangled up password. Let's run this again, but let's do test2 at asdf.com. Exact same password. And I click send. And now if I run this query again, and I grab this one, you can see that they're pretty different. Sure, it starts out with $2A12, but that's about it. Everything else is pretty random for the most part. So this is what the minimum of what you want to do when you're dealing with passwords and emails. You want to make sure that you've got all of that encrypted so that you don't know what the user's password is. You can check if what the user password is what they gave to you last time when they signed up, but you don't know what their password is. And that's the ideal. You don't want to know their password. You want to just be able to check if they have their password, if their password is the same between the two. That way, if your data gets stolen, and it will, you're not liable for a bunch of people's passwords, especially because people tend to reuse their passwords. Now, you might have to worry about plenty of other problems, but that's not a problem you're going to have to worry about because you just don't have their passwords. Cool. Now, this brings up the question of, okay, that's great. How do we sign in, right? How do we check that this mangles to be the same thing? And let's minus that one. Cool. So, any questions at this point? We're definitely going to bleed into office hours with this.
Would it be wise to, just for like security reasons, to hash the email as well?
You could, but then you don't have their email, right? Like if you're just using it as a login token, you could, but it's just an email. Like you could try and secure something like that, but then like a lot of times you actually want to have your user's email because you want to send them things like password reset tokens and stuff like that. So often you're not going to encrypt their email this particular way. You might encrypt them in a different way, but you ultimately, as an application, need your user's email most of the time. So you would have to have a way to undo it. And so you might have a key essentially, or a way of encrypting things where if you know the key, you can get it back. And that's stored outside the database or something like that. But that's not as important.
Thank you.
So short answer, you could do that. It's a bit more complicated than what we're getting into now. It depends on the nature of your application. But this is pretty universal, that you're going to have at least something like this. And this is just without even two-factor auth or anything like that. This is kind of the minimum that you would want to do. Cool. So next, what I want to do is I need to be able to say, hey, let me compare my password that the user gives me to another one. And to do that, we're going to make a custom method for our user. So we're going to say user.prototype.valid password equals function password. This is going to be that the password that they gave us. And since this is a user, we can use this password to get our password. So what we're going to do is we're going to compare the two. So we're going to return a new promise. So bcrypt.compare, the first one is going to be the password that they gave us, and then the next one is going to be the hashed password. So this is Hunter2. This is the gobbledygook that Hunter2 turned into when you hashed it. So this function right here lets us compare and say, hey, when I mash up Hunter2 in the exact same way that this is mashed up, do they match? And this is going to be asynchronous. This returns a promise. And you want that because you don't want user to be able to shut you down and brute force attack everything so that they can just keep asking over and over and over again. You almost never want to do anything synchronous when you're doing this kind of stuff, because what this will do, what bcrypt does a lot of times, and what a lot of software will do, is they'll logarithmically slow down your login attempts. And so the more times you fail to log in to a service, the more time they'll take in between responding to each request, so that a computer can't just brute force it over enough requests in actual production software. So these are always about trying to defend our users' data. Now, is this perfect? Is this the only vector? No, but it's one that you, especially as an application developer, should be aware of. Cool. So what we're going to do is we're going to switch gears and we're going to make sure that we can log in as that user. We're going to log in and then we're going to use that information. Now, to help us manage this, we're going to introduce another library, and we're going to call that library Passport. And what Passport is going to do is help us store all of that information. Now, if you're not getting this all at once, that's completely fine. We're doing this more as a record so that you can go back and watch all of it. This isn't an expectation that you understand all of this at once. We're just putting it all in one block so that you can look at it as you go. So don't worry about getting it all at once. So we're going to go ahead and bring in Passport. And Passport's a pretty common option, but it just allows you to keep track of some of this stuff. Now, Passport is going to require a little bit of its own configuration. Passport needs to know, how can I check if a user is when a user signs in, if they have a valid password? Passport is essentially going to manage for us some tokens. It's essentially going to be someone who sits at the front of a convention and hands out badges after checking driver's licenses. And then you can scan your badge throughout the rest of the convention, and they'll say, oh, I know who this is. And then they'll continue forward. So that's what Passport is. It's basically a service that gives you a badge that you can use for the rest of your application. So to do that, we need to tell Passport a couple of different things. So we're going to go into config, and we're going to make a new file called passport.js. So we're also going to need to add what's called a strategy, because Passport can work with so many different ways of authenticating people. Just the same way that Sequelize can work with so many different flavors of SQL, you also want to include a strategy. This is how specifically you're going to do it. And we're using Passport local right here. So we're going to say const passport equals require passport, const local strategy equals require passport local dot strategy. This is the only place in the application where these two are going to be referenced directly. Everyone else is going to reference our configuration of Passport. We're also going to need access to our models. So we're going to say passport.use new local strategy. Now, for the local strategy, we need to pass it two things. One is going to be, what's our username and password fields? And then one of them is going to be, what do I do when a user gives me a username and password field to check if they're a legitimate user or not? Those are the two things. So the first thing we're going to do is we're going to say that the username field is email. And then we could also say that the password field, well, that's going to be password. However, this is also the default, so you'll commonly see this omitted. If your username is username and your password is password, you can omit these fields. We're just going to leave them in there for now. So once that's done, the second argument that we need is, hey, I've got a function. If I give you their email and password, or their username and password, tell me, by calling this done function, if that's valid or not. I'm not going to know. I'm relying on you. Passport's relying on us to tell us. So the same way that someone who works the badge center at the front might say, just give me a system where I can check them in, see if they're there, and then see if they're valid or not after they show me their driver's license, if everything shows up. We're doing the same thing. So if we were to pseudocode this out, check if the user's email exists. If the user's email exists, are they valid? Maybe. If the user's email doesn't exist, are they valid for logging in? No. So if it doesn't exist, reject the login. If it does exist, check the password. If it's wrong, reject the login. Otherwise, issue the badge, we might say. This is what we need to tell Passport. Passport doesn't know how we're doing this, so Passport is passing it off to our program to ask that. So Passport is going to be storing this essentially in an array in a memory store that's just inside the server. It's just essentially going to keep a directory of here's a random number and here's information about the user or whatever you give back to me. So let's check if the user's email exists. Starting with db.user, how would we see if the user's email exists? Or see if a user exists with that email address, I guess would be more accurate.
Find one or find all?
Find one.
Find one.
Email.
Yeah, where email is email. And as a reminder, if you see anything as A:A, where they're the same value, you can just write email by itself. That's a shortcut. Those two are essentially equivalent to each other. Awesome. So when that happens, we're going to get back a user, or if there isn't a user, they're going to be a null value. So if that user doesn't exist, so if it's not a user, we're going to return done. And what are we going to pass off? First of all, we're going to say, hey, was there any, there's no error per se, it's just an invalid attempt. So we're going to return false for the user, and then we're going to include a message, and our message is going to be incorrect email or password. Now, why would we say incorrect email or password? We know that it's just an incorrect email.
Security reasons, so don't keep guessing.
Security reasons. We don't want people to know by using invalid login attempts, who has accounts with us and who doesn't. That's not their business. That's our business. And that potentially opens it up to other vectors, because if they can figure out, yeah, I found an account that's definitely here, they can narrow in on that with other forms of problems as well. And so we shouldn't be revealing if someone's email is right or not. Now that can be frustrating to our end users, but it's ultimately for their protection. So that's what we're going to provide there. Now, that handles this. If it doesn't exist, we're going to reject the login. Now, if it does exist, we've got a little bit more work ahead of us. So if we're going to say db user.valid password, that's that custom function that we wrote earlier. That custom function that we wrote in the user right here, valid password, that's what we're using right here. So if this thing has if the password that they gave us is valid, let's check that. So then valid password, if it's a valid password, or let's say is valid, that'll be a better name for it. If it is valid, well, then we're going to log them in. If it's not valid, we're just going to reject that again. So if it is valid, we're going to do something a little bit different. We're going to store that user, or at least some of that user, in our session. Now, remember, we don't want to store things like passwords and other stuff in there. So we're going to take some of those pieces out. So we're going to say const details equals ID, or let's say const ID and email. And let's say created just ID and email. So this is equal to our DB user. We've pulled their information out, and now we're going to say, hey, this is what you should pass along. Here's our object with an ID and an email in it, no other messages that we need to send. Because we're not going to use, we shouldn't be using their password on the front end. You could argue that, hey, we should use created at and updated at. In fact, let's go ahead and use that. Let's look here. That's created at and updated at. We'll pull those out there. Cool. Now there's one more set of options. One more thing we need to do. Because this is stored in like a memory store for us to use, we need to know, hey, and we're going to be giving out a badge, we need to know, okay, how do we pull the badge or the information off the badge, or how do we put the information onto the badge? In our case, it's pretty simple. We're just going to say passport.serialize user. This is here in case you wanted to talk to other services. For example, you needed to talk to other things like to talk to Google and get their user ID or get their profile picture or something like that. We can pull that information out as well without storing it ourselves. That's serializing a user, and then we'll just pull this information back out as well. For now, you can kind of consider this just to be boilerplate and copy and paste it from application to application. If you're curious about it more in the future, let me know and I'd be happy to talk to you about it. But we just need to define it in this case. You can think of these two things as boilerplate. Now that we've configured Passport, in this case, we can let the rest of the application use it. So that's setting up Passport, and that's a big, tricky part of this a lot of the time. So let's load that into our server, and then we'll build a login route, and then we'll be done for today. Tomorrow, during office hours, we'll look at some more of this, but I want to at least show you getting through this part where we can do that. So another things we're going to need to use up at the top, let's go ahead and say const passport equals require our specifically configured version of Passport, or Passport knows how to operate now because of that. And we're going to say a couple of different things. Oh, one more thing. We need to include sessions in npm install express session. A session is essentially just a big catalog. It's a big catalog that has IDs in one piece and data in the other piece. And that's what we're serializing and deserializing into. So we're storing, the user gets a randomly generated ID, and then we put all of their information into the session. It's like another place we can store it besides the database, but it only lasts as long as the server is up in this particular case. Let's set up the session, app.use. So let's put that up here. Const session equals require express dash session. We'll talk about that more next time. This needs a secret. This secret should not be in your GitHub repo. We'll talk more about how you can hide that in the future. Let's save it as please change me. Something, and then we'll set a couple of other options on there as true. For now, you can kind of treat that as boilerplate. Now, we need that session because Passport's going to use it. So this sets up our middleware. And in the same way that this middleware set up rec.body, this middleware is going to set up something called rec.user. And that user is going to be there so that we can access things about whoever is requesting this information. We'll know what user account they're associated with. So let's look at doing a login route here. Now, a login doesn't neatly fit into our REST APIs that we've talked about before. So we'll just kind of make a little one-off route for it. So we'll say down here, app.post, because they're going to be sending information /API/user/login. It's kind of a special thing. They need to send us the information, so that's going to be in a post request. So it's a little bit different than our standard, but it still has to do with the user, so we'll just keep this one here. You could also just say API/login or something if you wanted. Now, what we're going to do is one of two things. We don't want to actually handle this ourselves. We want Passport to check for us, is this user valid or not? If the user's not valid, Passport will reject it. If it is valid, then it will continue on to this function. So we're going to, in here, put passport.authenticate local. So it's going to look at the body of this request. It's going to look for something labeled email. It's going to look for something labeled password. And then it's going to run that function. that we just set up that verifies, hey, am I part of the database or not? And if that works, fantastic. If it doesn't, it'll reject it for us without us having to write that rejection ourselves. So if we get to this piece and our middleware hasn't rejected, then we can just send back the pieces that we want. And we're going to send back the email, rec.user.email, and our ID, rec.user.id. Again, we don't want to send the password. And this is what's been stored in our session. So this is what we're pulling out of our session. That's what rec.user is after we've authenticated. And in fact, we can ask on any subsequent check, hey, do we have a rec.user? If we do, we can tell things like what's their ID, what's their email, and use that in database queries, for example. We know who's asking at this point because they're authenticated. So let's go to let's start up the server. Let's go over to Postman. Let's do API/user/login. Let's click send right now. It says unauthorized, and that happened because we restarted our server, which means our database dropped, which means we haven't signed up with anything yet. So let's go ahead and just copy this. Let's make another tab. And we'll say body, and we'll copy over all of this. So we'll say the body is a raw JSON document. Now let's click sign up. So API/user, and that'll be post, send. And so it's been created. Fantastic. Next, let's go ahead. And if we look here in, so now let's try this again. We click send. And now it gives us that information back. Now, you might notice that we have this piece right here, this connect.sid, and it's set to HTTP only. This is a cookie, and more importantly, this is an HTTP only cookie. It can't be accessed by JavaScript on our client. The browser's there, the browser has it, and it will send it with each request that we have. This is our badge. This is our badge, and when we pass our badge into the system, Passport will go, oh, look at that badge, and populate rec.user for us based off of the information in the session. So this is our badge. So if I clear this out and I make requests that require things, a user to be there, it's not going to work. So let's add one more route real quick. And we'll say, hey, based off of if it worked or not, app.get/API/user/details. Res if rec.user. So if we have a user, or rather if we don't, we're going to say res.status 401.end can't be here. You're not logged in. Otherwise, we'll say res.json rec.user. And this will tell us, are they logged in or not? Or information about them. We could even make other queries. Like we could say, hey, let's get the to-dos associated with this user. And we'll look at that more on Monday during office hours. But let's go over to that. We just logged in successfully, but unfortunately, because the server reset, not only did we lose our session, so we have to re-log in, our database is set to force true in our server. So we're losing all of our data each time as well. I'm going to set this to false. We'll still have to re-log into the server because it's resetting every time. But this is one reason it's nice to keep these up in Postman, because then you can just go, I signed up. I'm logged in. You don't have to retype everything over and over again. So now let's try visiting /API/user/details, let's say. There's the currently logged in user and all of their information that we had associated about them. Cool. Questions? And I know it's Friday and it's fried, so don't worry. If you come up with questions later, you can still ask them then. I just want to ask if there's any right now. That's why they call it Friday. Ha ha ha. Right on. We still got 10 minutes left in office hours. So what I'm going to do is build a UI that works with this so that we can see it fully in action from this point. So we're going to go back to our public folder. We're going to go into login.html. I'm going to copy what I have on the sign up page over here, except instead of going to API/user, we're going to say API user/login. And if it's successful, instead, we're going to redirect them. We'll redirect them to the profile page. So we'll say window .location .href equals /profile.html. If it was successful. Otherwise, we're going to say, hey, something went wrong. We'll keep the same things. We'll say login here. The other one here should be sign up. And this one should be login. Cool. Profile. Again, I'm going to just copy a lot of what we have here, but we're going to make a few quick changes. I'm going to just comment all of this out for now. Cool. We should be able to keep the same login that we've been using. So let's go to login.html. This is our username. This is our password. And now we're on the profile site. Cool. I'm going to change the button on that really quick. Let's actually minimize that so I'm not looking at that. Now on the profile page, let's go ahead and say $get/API/user/details. Then we'll take our user and we will say const ID, email, created at, modified at, I believe is the name. Actually, it'll just work with created at, though we could use more. Hashtag profile info.html. Then let's just build a nice little template string for it to use. H1 email. And we'll actually lift the paragraph. A proud member since let me grab a link to the moment CDN real quick. Moment created at dot format month. All right. So there's test2 at ASDF.com, a proud member since July 4th, 2020. So I'm going to add one last thing here, and then we'll be done. Wouldn't it be great if you could sign out of the website, right? That's some pretty basic functionality. So let's go back to our server, and let's just make a route for that. app.get, let's /API/user/logout. Function, recres. Fortunately, this one is actually pretty easy. We're going to say rec.logout. In fact, we're going to just make it basically a user HTML route. Then we're going to say res.redirect, and then we'll redirect them to login.html. And now, if we want to do any of this stuff, on profile, we're just going to have the ability to sign out up at the top here. So we'll put this. A href equals /logout sign off. Let's refresh the page. We're already not logged in because our server reset. So let's go log in by going to /login.html. We'll sign in using our cool test2 at ASDF.com, I believe. We'll log in. Proud member since then, and then if I click sign off, it brings me back here. So that is what you need for the very basics of users. Oof, quite a lot. but we put it all into one later in office hours next week. We will look at how we can connect this to other pieces of data, as that is something that you will need to be able to do for project 2. A copy of what I've done is already in your supplemental folder. So you'll have a reference to all of this code. It's slightly different from what I wrote here, but I'll be pushing this up in a little bit and posting it along with the video for this once this is done. Is there any questions I could answer at this point?
Are you gonna discuss project 2 on Monday?
Yes.
Or when do we start? Okay.
Yes, we still have a little bit of content we need to get through first. Because of the July 4th weekend, everything got offset a little bit. So we'll actually be starting fully in earnest on project 2 next Tuesday.
Awesome, thank you.
Cool. But in short, project 2 is going to be a lot like project 1. The only difference is we're going to be having you use these technologies instead. But similarly open, the groups will be about 4 to 5 people. Who we will be assigning. You'll learn your groups on Monday. And then for project 3, you'll get to pick your own teams at that point. Within limits. If you're like, it's team, the cohort, I might be like, maybe not, but. All right. Again, I want to emphasize, if that was a ton of information and it blew past you, that's completely okay. That's normal. I just threw a ton of information at you. What we did is we wanted to put it all as one big block so that you could go back and reference it. I would encourage you to do that over the weekend. Go back, process it at your own pace, use the video, pause it, follow along, look at each one of the pieces and see what they do. If you're feeling like this is a lot, it took me a while to get it too when I first learned it. So don't feel like if you're feeling overwhelmed, that's normal. That's completely fine. But if there's no more questions, it's Friday, and I've kept you long enough. Any final last call for questions? All right. Have a good one, everyone. We'll see you on Monday.